This is the beginning of our third unit, and we're going to start by discussing polynomial functions and models of polynomial functions. So of course we have to do some definitions first. A polynomial function in one variable is a function of the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus, and it keeps going until we get down to a sub 2 x squared plus a sub 1 x plus a sub 0. So all those a's with the different subscripts are just constants, and we should all know by now those are the coefficients of the polynomial. And n greater than or equal to 0 is an integer. And of course, x is the variable. If a sub n is not equal to 0, so in other words, the coefficient on our largest power of x term, we call it the leading coefficient. And n, the highest power of x, is the degree of the polynomial. So the domain of any polynomial function is all real numbers, or negative infinity to infinity in interval notation. The leading term is the leading coefficient with its variable, and the term at the end, the a sub 0 that has no x, that is our constant term. So a polynomial is in standard form if the terms are listed in descending order of the exponents. And the graph of any polynomial is a smooth, unbroken curve. And by smooth, we mean it does not have any sharp corners. Sharp corners are things that we get with, like, the absolute value of x. If you remember from our library of functions, the absolute value of x has a graph that looks like this, and this is a sharp point right there at the bottom of the v. And unbroken means we can draw it without ever picking up our writing implement. So determine which of the following are polynomial functions. If they are, give the degree. If they're not, explain why. So if we look at this first one, this is a polynomial function, We know that because all the coefficients are real numbers and all the exponents on x's are positive integers. So the degree of this polynomial is 2 because that's the largest exponent on x. Let's look at problem B. H of x equals 3x to the 2/3 minus 5. This is not a polynomial function. And that's because of the 2/3 exponent. Remember, all the exponents have to be non-negative integers. And this is not a non-negative integer. Okay, at this point you should pause the video and try to do the other three on your own, and then restart the video and go through them with me and see if you got them correct. So, assuming that you've paused the video and tried these, C is also not a polynomial function. And we know that because -3, while it's an integer, is negative. So it's not a non-negative integer. Okay, D is a little tricky because there are no variables in here at all. However, this is just a constant function, so this one actually is a polynomial function. And its degree is 0. And that's because this is just a constant and has no variable attached to it. Although really it does have a variable, it has an x to the 0 power, which is what makes it degree 0. But what is anything to the 0 power? Well, anything to the 0 power is just 1, not -1. Don't know why I wrote that. Is just 1. And so there's no reason to write the x to the 0 power there. What about the last one? Right now, it doesn't look like a polynomial, right? Because it's not in that form. But if we distribute this through the 3s, we get 6s cubed minus 3s. And now it's clearly a polynomial function. And its degree is 3. That's the basics of polynomials. We will start talking about power functions and how their graphs look in the next video.